All right, so now we're going to come down here and look at number 4 down here. So is A the inverse of B? So if you remember how that goes, you could go ahead and find the inverse of matrix A and see if it matches matrix B. You could also go ahead and, find the inverse of matrix B and see if it matches matrix A. The other way you could do here is you could multiply matrix A here. You could go ahead and see if you multiply these two matrices together here, do they end up giving you the identity matrix? So I'm just going to rewrite these down here. So I could multiply those two together and see if they give me 1, 0, 0, 0, 1, 0, 0, 0, 1. And if they do, if they end up equaling it, then yes, they are inverses of each other. Like I said, the other thing you could do here is you could do 1, 3, negative 1, 1, 4, 0, negative 1, negative 3, 2, and then find the inverse of that matrix. And it should, if they're inverses of each other, it should equal B. And vice versa, you could do 9, negative 10, negative 8, negative 12, 14, 11, negative 1 half, 1 half, 1 half, and do the inverse of that and see if this is the same as matrix A. If it is, then they are inverses of each other. So that's the way you want to do those. So I'm actually not going to walk you through that one. I think you pretty much have it by now. But that's how you want to think through if they're inverses of each other. So then find the determinant. I said I'd show you how to do that on your calculator there, so let's do that. So how you find the determinant on your calculator is go back into your matrices there. Whoops, wrong spot. So second matrix. I'm going to go over to Edit, and a matrix A here is a 2 by 2. And so I can punch in 4, 1, 7, 2. And I realize doing it this way is a lot more work than just finding it by hand, but just kind of showing you how to do this. And so then I could get out of this. And then I'm going to go back into my matrices. I want to go over to math this time, and I want to go where it says DET, that's the determinant. So now if I bring that up on my screen, and then I want to go back in and get the name of matrix A there on the screen, and hit enter there, and it tells me it's 1. But we already knew that because AD, which is 8, minus BC, which is 7, gives us 1. It's a whole lot easier to go ahead and do it by hand in this case, but that's how you do it. You go the DET of your matrix there. 4, 1, 7, 2, and it gives you an answer there of 1. All right, and then even this one down here, that matrix there, it's a 4 by 4. Well, we haven't done a 4 by 4 by hand or anything, but again, your calculator could do a 4 by 4. So if we wanted to do that, we'd enter exactly the same thing, but we put a 4 by 4 in there and do the DET of it, and it's also going to give you the determinant of that. I'm not going to do that one. All right, so then the next one here says solving the system of equations by converting to a matrix equation and using the inverse of the coefficient matrix there. So let's go ahead and do that. So solve the system of equations. We're going to convert it into a matrix equation. So we can do that. That is 4, negative 1, negative 7, negative 2 times xy equals a constant matrix of 10, negative 25. So then if you remember how this goes, you can multiply over here by the inverse of this. So 4, negative 7, negative 1, negative 2, the inverse of that, which means then the inverse of that has to go in here. So 4, negative 1, negative 7, negative 2. So when you multiply these two together, you just get the identity matrix, and you can multiply that by the matrix XY. You just end up here with the matrix XY. So now you can simply do 4, -1, -7, -2, the inverse of that matrix, and multiply that by 10, -25, and that will give us our solution. So let's put that into our calculator there. So I'm going to do that. So if I enter those matrices in there, I can go second matrix there. Whoops. There we go. I'm going to edit matrix A there, and it's a 2 by 2. So 4, then -1, then -7, and -2. So there I've got matrix, the first matrix. Now I'm going to go back in there, the second matrix there. I'm going to edit matrix B. That one there is a 2 by 1. So 2 rows and 1 column. And I'm going to put in 10 and then -25. So now I can get out of that. I can go back in there and I can get the name of matrix A there. Since I want the inverse of it, I'm going to take it to the -1 power there. And then I'm going to go in and get matrix B there. And I end up getting the solution there of 3, 2. So now I can say xy equals 3, 2. So my solution there is just the ordered pair 3, 2. So that's how you can use the inverse equation and solve it on your calculator. So that this one here, again, you would just set this one up the same way. The only thing I wanted to make sure that you saw with this one here is if you don't have a variable and you're missing one of the variables in your equation there, that this is going to be a plus 0z. So when you put in your equation there or your matrix there, don't forget to put a 0 in the matrix there. So then we talked about reduced row echelon. So I want to show you, remember the goal there is for a 3 by 3, 1, 0, 0, and then your numbers over here, 0, 1, 0, and then your numbers in, usually in the last column is your solution, but not always. 0, 0, 1, and then the last column is your solution there. And then with a 2 by 2, 1, 0, and your solution's in this last column, and then 0, 1, again, a solution is that last column. So you did it by hand. So I wanted to show you now that there's something on your calculator we can actually do this on as well. So for this one here, let's go ahead and write the expanded matrix here. So if I write it out here, because that's part of our directions of how we're going to do this. -2, 1, I'm just taking the coefficients of what's in front of x, y, and z. And then my constant term on the right-hand side, I'm also writing over there in the last column. All right, so that's the expanded matrix there. We're going to do the RREF of that. That's reduced row echelon form there. And the calculator will tell us what that is. So you're going to write all this out. So that's what this part here is. I just did that. And now I'm doing the second part by doing this over here. So the RREF of that matrix, I'm going to put in my calculator, and then I'm going to list out what that matrix looks like on my calculator. So I'm going to go into, again, my matrices here. I'm going to go over and edit matrix A there. Matrix A there is 3 rows and 4 columns, so it's a 3 by 4. So I've got 3, -2, 5, 3, and then row 2, -2, 1, 4, -2, and then the last row there is 1, 4, -7, 1. All right, so I'm going to get out of that. So I did second quit. Next thing I want to do here is I want to go into my matrices here again. I want to go over to math, and then all the way down the list you're looking for RREF. Now I'm going to go backwards because mine's toward the very bottom, so I'm going to go up, and then I can see RREF there. Whoops, too far. RREF. And then we're going to take that of the matrix we just put in there, was in matrix A for mine here. And then there's the solution there. We've got 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's this part, 1, 0, 0, 0, 1, 0, 0, 0, 1. And then if we look at the last column there, that ends up being the solution to our matrix there. The last column there says that we've got 1, 0, 0, looks like. Typically, your solution is in this column. However, it's not always. So that's what we just did. We showed what the calculator provided there. And then my third step here is I want to give the values of x, y, and z. So I could say x equals 1, y equals 0, z equals 0. And I like just to write them as an ordered triple. And then you could double check and put them back into those equations up there and see if that's true. Or is my solution 1, 0, 0? And they are. All right, so let's do one more of those. So example 10 here, RREF there. It's pretty simple. So if I go back in there again, before I do that, let's write it out. So if I wrote out my matrix there, expanded matrix there is what I want to do here first. So I'm going to do RREF of my expanded matrix, which is 3, negative 2, 2, 6, 2, negative 3, 4, 0. Just take in, and if they're not in order, you got to put them in order. All of your x, let's go x, y, z equals your constant over there. X, y, z equals your constant over there. X, y, z equals your constant over there. So then 7, negative 3, 2, negative 1. So we got to put in that 3 by 4 into our calculator. So let's put that matrix in there, and then let's take the RREF of that. So second matrix, I'm already in there. I'm going to go over and edit matrix A there. I've already got a 3 by 4 in there, so now let's just put our new numbers in there. 3, negative 2, 2, 6, row 2, 2, negative 3, 4, 0, and the last row 7, negative 3, 2, negative 1. So since I've got my matrix there, now I can come down here, second matrix there. I have to go over to math key there. We're going to do RREF. I'm going to go get the name of matrix A there. And notice this time they did not put it in the last column. They actually put it in the third column, our solution there. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. And then our solution there, they happen to put it in the third column this time. And our solution there, negative 0.4, negative 1.6, and 0. Negative 0.4, negative 1.6, and 0. So this is my solution this time. So we just did the second step, the third step. I'm going to write it out as an ordered pair. negative 0.4, negative 1.6, and 0 is my solution. All right. So that's how you use RREF. It's programmed in there to do exactly what you did mathematically, algebraically, with your rows and your columns and multiplying by numbers and adding things together. All right, so we're not going to do that one. I'm not going to have you do one. So you're going to work on the calculator worksheet and then do those. And then yeah, that's good enough. Just do the calculator worksheet for this time. So